you mentioned, I normally do these presentations with John Keller, and he's in Germany right now, so he's unable to attend. And I thought, well, that's actually okay. It gives me a chance to do something a little different this year, and maybe to use a few bigger words in my presentation than I normally do. When I was going to try to do something different, I was thinking about what I could do that would be both interesting and educational. Put a lot of thought into it. And I couldn't think of anything, so I'm going to present on our water efficiency programs reaching the end of the line. I'll try to go through this quickly, and as I say, yes. So I think I have some time for some questions. Maybe I'll see if I have any more. I'm actually interested to see what I came up with at the end. So I say we have miles to go before we sleep. Obviously, I can't go into a lot of details on a lot of these because there's a lot of many items to cover. But this is kind of what I'm going to try and cover really quickly. A lot of this is my view and my opinion, which doesn't necessarily mean it's right, but in this case it is right. So we have falling demands. This has been stated many times in this conference that demands are falling, and this is specifically residential indoor demands, and that's what I'm going to deal with here. In fact, these demands are falling in virtually every community in North America, which is pretty amazing. It either means we're doing a very good job or something else is happening. Now, everybody knows this. In 1994, National Energy Policy Act mandated the use of 6 liters, you can tell them from Canada now, 1.6 gallon toilets, showerheads for water efficiency, etc. Now, before 1994, the average indoor water demands were about 69 gallons per capita per day. Now, this is, again, indoor single-family water demands. As has been said earlier by other presenters as well, people compare demands differently. Some do the gross per capita day demand, the total water they produce divided by the population. Others residential, indoor, and outdoor. But because there's such a variation in outdoor demand between the warm states and the cold states in Canada, I'm just dealing with indoor demands. Current efficient homes have a demand about 36.6 gallons per capita per day. And that's a savings of almost 50% in 18 years. And this is remarkable, but why is it happening and how far is it going to go? Some people have said, well, it's because of the recession. Well, in fact, no, it's not. This was happening long before the recession. The major reason for this savings, and like the fact that one is WC and one is CW, water closets or toilets, we're saving about 67% of the volume that we used to use in them, and yet we're using them exactly the same way as we always did. There was no learning curve. We just simply, the average is about five flushes per day per person at home. We're still doing that, but because of technology, we're saving 67%. Then they were between 3.5 and 5 gallons. Now they're between 0.8 and 1.28 gallons per flush. Clothes washers, same thing, saving about 63% of the volume. Then it was approximately 13 gallons per capita per day for clothes washing. Now it's about 5 gallons per capita per day because we have efficient front-loader washers that automatically adjust the water level. I have to say there is some honorable mention to showerheads. Showerheads used to flow all over the board, 5 gallons a minute, what have you, but now they're down to 2 gallons a minute. Faucets and aerators, not a huge amount of advancement there, primarily because even if a faucet can run at 5 gallons a minute, except for a kitchen faucet, nobody's going to turn it on. Nobody goes into the bathroom and turns their lav faucet on at 5 gallons a minute, they'd be drenched. Dishwashers save a little bit as well. There is fewer leaks, we have better toilet flappers, we're fixing the leaks. Behavior, we're becoming more aware that we're wasteful, and so we're starting to change. And of course in Canada, we have new ways to flood our ice rinks for the 10 months when it's freezing. Anybody been to Canada? Okay, so we have the market forces. We have the older homes used about, as I said, 69 gallons per capita per day. Standard new homes built just to code are using about 44 gallons per capita per day, and efficient homes are using about 36. Now, this is the market forces. So new homes, most new homes are between 36 and 44 gallons per capita per day indoor residential use. Clothes washers, they're changed about every 12 years. That's the market standard. Toilets, 20, 25 years. market standard. In most places now, it's very difficult to find an inefficient toilet. In the States, I think it's impossible. The worst you can find is 1.6, and all the manufacturers are starting to build 1.28 or 1 gallon toilets. I did a quick survey of Home Depot and Sears. I don't know if you have Sears here. Do you have Sears here in the States? Yeah. And more than 50%, about 60% of the washers they sold are front-loading washers. They used to cost $2,000. Now they're costing like $500. So what's happening is the new homes are having efficient toilets and clothes washers in it, and the old homes, when it's time for the people to replace their fixtures, they almost cannot find inefficient fixtures, so they're replacing them with efficient fixtures. So this is the natural decline in demands. Every time a washer's change, right now you have a 50-50 chance that it's going to be, or say a 60-40% chance that it's going to be an efficient one, and you virtually have probably 80 or 90% chance that your toilet is going to be an HET if it's replaced. Now we look at energy versus water. Now some of you may wonder what that picture is, and that's of course the energy water Lexus that Marianne Dickinson was talking about earlier in her presentation. But every day somebody's developing something new for electricity. Years ago, microwaves, now we have iPads, cordless phones, whatever. Every day we're using more and more electricity. We're coming up with more and more ways to use it. But there's not too many ways new ways to use water in the home. In industry, and somebody mentioned fracking earlier, yes, that probably didn't exist 50 years ago. But the other things like toilets, showers, baths, clothes washing, cooking, cleaning, drinking, irrigation, those all existed hundreds of years ago, and they still exist. We're doing the same thing, but now we're using technology to become a lot more efficient. Now the question is, when you drop a ball, I thought somebody's waving at me back there. When you drop a ball, it only falls until it hits the floor. So we have a natural decline in demands right now. And this is going to happen. Right now, in communities with water efficiency programs, the demands are falling at greater than 1.2 gallons per capita per day per year. And in communities with no programs, it is about 1.2. In communities I've seen with water efficiency programs, and not even incredibly aggressive water efficiency programs, but just promoting things and offering a few rebates, it's more like 2.4 to 3 gallons per capita per day per year. And a lot of people I deal with, they don't believe that's happening, and they don't believe it's going to continue to happen. But as I say here, unless things change, these demands are going to level off at somewhere around 40 gallons per capita per day, indoor residential demand, over the next 20, 25 years. And that's simply because it's going to be virtually impossible to get inefficient toilets and clothes washers. So if we don't do anything, this is going to happen. This is the market taking care of itself. This is an example. I did a lot of billing data analysis for many, many communities around Toronto, and this is an example of one. And I chose this example because it's incredibly linear. The blue wavy line is the total demands for the year, divided by the total residential demands divided by the population. And you can see that in the summer it's higher, in the winter it's lower. But if we just take the winter demands, just the demands in Canada, that's from June 3rd to May 31st, winter demands, you'll see that they're very, very linear. And it's dropped from, in 1998, 60 gallons per capita per day, in 2010, 46. And this is going to continue to happen until it reaches around that 40 or a little bit less gallons per capita per day, and then it's going to level off. Could we go lower than 40? We could. We could if either technology or behavior changes. If technology changes, such as the clothes washers and toilets, then it's going to be inevitable that we do go lower than 40. If it doesn't change and it's just behavior, then it won't go much, much lower. But remember that 40 is the average. I predict that 40 is going to be the average. And so, as I said, the efficient new homes are at 36. They can get down to 30 gallons per capita per day without sacrificing. But it's putting things in such as hot water recirculation systems and efficient humidifiers and softeners, etc., and very efficient toilets. I mentioned there the toilets. We're down to 1.28 gallons. I did a study years ago on drain line carry, and my prediction at that time was that 0.8 gallons was about as low as you could go and still move the waste through the drain line, still feel comfortable that you weren't going to get plugs. So if we went from 5 gallons down to 1.28, and all we can go is from 1.28 down to 0.8. We don't have much room more to go unless we change our drain designs, steeper slopes or what have you. New technology in clothes washers are possible. I've heard of things for years such as sonic clothes washers or ultrasonic washers, but I've never actually seen one. I don't know if they're going to make it into the market or not. Change in habits, we could certainly do that. I think most of us, if we go camping or something like that, we would say, well, we're going to wash with a cloth and some soap instead of taking that 7 or 8 minute shower. But we could get used to, if it becomes the norm, to take fewer showers, take shorter showers, or maybe not wash our clothes every single time we use them or whatever. So that's a possibility, and if that happens, again, we'll go down below 40 gallons per capita per day. So whether you like it or not, in 25 or so years, the residential indoor demands are going to be about 40 gallons per capita per day, my prediction. Almost nothing we can do to stop that. It might be a little lower. It's not going to be any higher. So I say that programs to accelerate this natural decline are more suited to water short areas. So if you don't have a water shortage area, you're on the Great Lakes or something like that, and you're paying to replace toilets or promoting toilets, whatever, giving rebates out, then you're not really doing yourself a favor because it's going to happen anyway and you're just paying for it. So you should put your efforts into different areas. Design your rate pricing accordingly. As I said, some people I deal with, they don't believe that that trend is going to continue, so they always go back and go, well, what was it 5 years ago? Let's base the rates on that, and then they're always short revenue. So not only do you have to say that it's lower now than it was 5 years ago, but it's going to continue to get lower and lower until it levels out at about 40 gallons per capita per day. So that was that part. Full cost pricing. I'm not a full cost pricing expert, but and everybody is aware of this. Water is so inexpensive. Less than 1% of household income. Some countries is 2 or 3%, but in North America it's typically less than 1%. But I say even full cost pricing will have a limited impact on non-discretionary demand. So once we get down to around that 40 gallons per capita per day, you can raise up the price, the base price of the water, and it's not really going to have much of an impact because people, unless they change their habits, are still going to flush a toilet 5 times a day, still going to wash their clothes, still take a shower. So it always was relatively inelastic. It's going to get more and more inelastic as we go along. And I say there, you'll never pay what water's worth. Water can't live without it, so you can't put a value on it, but we'll never pay that. And because of full cost pricing, we can't arbitrarily charge more than it costs us. So I say that the pricing, we can price it to impact irrigation, but not really indoor demands once we get down to that 40 gallons per capita per day. There's been some talk, what about we embrace to get down below that 40 gallons per capita per day gray water reuse? I personally don't see much impact of gray water reuse simply because it's not cost effective, and it's not marginally not cost effective. Right now it's not even close to being cost effective. Even more harmful to it is the fact that there's maintenance requirements. And the people I know, and I'm working on a project now in Canada, where most of the people are saying once the project is over and the monitoring is finished, they're going to take it out. They're going to just quit using it because they don't like the fact that every 2 or 3 weeks they have to go down there and clean it and change filters. They didn't expect that. For what little they're saving, they're not getting the bang for their buck. They also have a higher per unit energy demand than municipal systems. So whatever you pay, whatever energy is used to get that water from a municipal distribution system to flush your toilet, you're going to use about twice that if you have your own gray water system. So if we all switch to gray water systems, the energy bill is going to go up. The other thing is, gray water reuse systems are more efficient if you have inefficient fixtures. If you have terribly inefficient showers, you collect a lot of gray water. You have terribly inefficient toilets, you use a lot of gray water. If you have efficient fixtures, it makes it even less cost effective. So I say there, if you use the gray water for flushing a high efficiency toilet, a 1.28 gallon toilet, you can save a maximum of 6.4 gallons per capita per day. If you're going to use it for irrigation, so what happens with the toilet, if you're collecting it, say, from showers, this is only from showers, you collect more than you can use. And if you're using it for irrigation, you would use it all, so you would use 10.5 gallons per capita per day. But the people who are putting these systems in are not doing it to save money, they're doing it to be green. Unfortunately, I don't see that as widespread across Canada and the USA. There's going to be people that do it, but it's never going to knock the average demand much lower than 40 because it's only going to affect a very small percentage of the people. Next, residential rainwater harvesting. I again believe that residential rainwater harvesting will have little impact on North American demands. And you can read why. Uncertain supply. Here's something that a lot of people don't consider. If it's widespread, right now when we flush our toilet, that water goes to the water treatment plant, or the sewage treatment plant, wastewater treatment plant gets treated. If we're putting rainwater down there, we haven't paid for that water in any way, and yet we're adding to the wastewater treatment load. So somehow the municipality is going to have to come back and say, we have to charge you something if you're putting rainwater down your toilet. You need backflow prevention. You may need that inspected every year. You also have to maintain it. So for single family, I don't see this as being a big impact. Some people will put them in. They can work. They work in other places, but I really see it as a very, very, very small percentage of homes to have these. They could be used for irrigation and have much more impact, but I believe that, and you can see the on the bottom, I say on a 24 by 40 foot roof, the maximum you collected if you take the average precipitation across the contiguous states is about 18,000 gallons a year, about $120, 16 gallons per capita per day. So even if you use it to the maximum amount, it's not going to be hugely impactful. I see like stormwater reuse is much better use. We have, every time it rains, the water goes down the roads and the sewers and goes into the creeks and the rivers and back into the ocean, and we lose that, and that's fresh water. So I can see a use for that, but individual rainwater harvesting systems, I just can't see people doing it. People don't change the filters in their car. They don't change the furnace filter on time. I don't think many people are going to manage a rainwater harvesting system. Okay, so let's look at WaterSense in the next 25 years, and 25 years from now. We have the big three, which are toilets, clothes washers, and showers, and we say that once, and this is, I think, inevitable, once 1.28, once HETs are mandated and become the market standard, then WaterSense, by wanting to be 20% more efficient, has to go down to 1 gallon per flush. If the manufacturers step up to the plate and start producing 1 gallon toilets, that becomes the market standard, and then WaterSense would have to be 0.8. And then, if the manufacturers step up and produce 0.8 gallon toilets, then WaterSense has nowhere to go because 0.8 is about as low as you can get and still get your waste through the drain line. So for toilets, in 25 years, toilets may fall off the WaterSense list. And even now, there's a decreasing incremental savings. Every time they improve, that 20% becomes smaller and smaller. Clothes washers, most if not all Energy Star clothes washers, they adjust the volume of water used based on the load. So if you put a pair of socks in there or 5 pair of jeans, it will automatically adjust the water level to make sure that it's the proper amount of water up to a minimum to wash your clothes. So as I say, there's potential for a new system to come out, but unless that technology changes, I think we're able to improve them a little bit more, but we're getting to the point where it's going to be very difficult to get any more savings out of a clothes washer. Showerheads, the studies that have been done showing that showerhead is very personal, very tactile. Somebody who's got very short hair may like a certain type of shower that's very, very low, a gallon a minute or whatever. Somebody with long, thick hair doesn't like that. So unlike a toilet or a clothes washer, showers, if we go much lower than somewhere around, we're not quite at 1.5 for everybody yet. We may be able to get there, but we're not going to probably get anything lower than that. So again, incremental savings are less and less. I always laugh at this. There's a common belief that North Americans, and I should say this, the actual saying is Americans are the worst, Canadians are the second worst, but worst water wasters in the world, and Europeans are super efficient. Boy, they really use water efficiently, and we don't. But now our new homes are as efficient as their new homes. And I say, if you have an efficient home with efficient toilets, clothes washers, showers, hot water recirc, whatever, it's very difficult unless you decide, I'm not going to shower as much, I'm not going to wash my clothes as much to get anything lower. And here's an interesting stat. In Jordan, I worked there for a couple summers, and the average demand there is 25 gallons per capita per day. This is a desert. These people have grown up where they get no rain, always a desert. They get their water delivered 1 day a week. They store it on a tank on their roof, and they use the gravity from the roof to run their toilets and whatever. And they never drink or cook with that water because it's an open tank. Well, covered, but it's essentially open to atmosphere. So they're at 25, and they're about as efficient as you can get. So when you add cooking water and drinking water, they're up around 30. And I said we could easily get to like 35 or ish without sacrificing. And I don't think anybody would want to sacrifice and say, just give me water once a week and I'll deal with it from there. So we are getting to the point where indoor demands are almost as low as we can get. So I say, if we want to sacrifice, we can get lower than that. And they say WaterSense wants to be 20% more efficient. So as the marketplace improves, that 20% becomes smaller and smaller and smaller. So I think one of the big opportunities is residential irrigation. Up north, we're finding that even though indoor demands are falling by this steady 1.2 gallons per capita per day or more, outdoor demands don't seem to be falling by anything like that. They tend to be staying the same, which means that the peak day ratio is actually increasing. And part of the reason for this, the analysis I've done shows that the average homeowner that doesn't have an automatic irrigation system has say a 40-foot by 125-foot lot, call them hose draggers. They aren't typically overwatering. They're putting down about 1/3 of an inch of water a week. But automatic systems are putting down 1, 2, or 3 inches a week. And more homes up north. It used to be if you were a big commercial facility or an estate lot, you would have an automatic irrigation system, but the average homeowner didn't. And now we're finding that more and more average homeowners with 40-foot lots are putting in, either getting them installed or putting in these do-it-yourself automatic irrigation systems. And if they do that, then the demands are going to keep going up and up and up. So WaterSense has a real opportunity, I think, with these irrigation systems, especially the do-it-yourself or for the small homes. Waste carry through drains, that is something that was mentioned during one of the panel discussions, I think. As we keep reducing demands, the drains were not designed to flow at these low rates, but they weren't necessarily designed to flow only at the full rates, because when a lot of the sewers are put in, the homes are not fully occupied, the subdivisions are not fully occupied, and you're not having problems all over the place. But the question still remains, how low can we go before all of a sudden we do start affecting, if we do start affecting our sewers. We say that there's a PERC study going on. Pete DeMarco is involved with that. And soon we're going to have some answers, I hope, and we'll decide which way to go. But if anybody has deep pockets, I know that the study is doing a lot of good work now, but there's a lot more to be done. So if anybody wants to pony up with some money, I'm sure Pete would gladly accept it. Due to the effects of revenues, almost finished now, guys. Water agencies are in the business of selling water, we know, and we know that by far most of the costs associated with operating a water treatment and distribution system are fixed. Typically, from what I hear, is 90 to 95% of the costs are fixed. So a lot of municipalities include a fixed fee on the water bill. They may call it a meter fee or a connection charge, what have you, but there's always some fixed fee on there. And the reason they do this is they tell me, well, fixed fees prevent revenue shortfalls. Now we say they don't. If 90 to 95% of your costs are fixed and you're only charging 10 to 15% as a fixed fee for a meter charge or whatever, if nobody uses water, you're screwed. You haven't got enough revenue. So that's not a good argument. If fixed fees truly reflected fixed costs and 95% of your water bill was fixed, then why even put in meters? Why pay meter readers? You don't need to, because you're basically charging them a flat rate. And then I also asked them, I said, what are the odds of not selling any water? You've never once, no municipality has ever gone where they go, well, we didn't sell any water last year and we have all these fixed fees, so we don't know how to cover them. So your base demands are there. They're very predictive. You can predict them several years out. Discretionary demands, not so much, they change with the weather. But I've analyzed, this is just more for curiosity, I've analyzed a lot of water billing data sets, and on this next graph I'm going to show you, I sort them from, these are residential, from smallest to largest. And every one I've done, I get the exact same pattern. And some accounts, they say use little or no water every day. And at first, when I first did the first analysis, I couldn't believe the results, but they all look like this. And the reason I put this on is because if I said that the average, and this is in liters per household per day, but if I said the average, if somebody told me the average for your town, indoor single-family residential demand was 650 liters per day, I would totally believe it. But when you look at something like this, you go, but there's only a couple houses at that actual demand. Everybody else is below or above. And it's amazing how many homes use almost no water. And these could be homes where the son always goes to the mother's to do laundry or his girlfriend's or whatever, but every place has a number of homes that don't use water. So what I did is I said, let's compare if we had a strictly volumetric, and the fact that this is in meters cubed doesn't matter, it's just that the way the numbers come out is important. So I took an actual set of data, like from that previous graph, and I said, let's just say we charge $1.50 per cubic meter. So no flat fees, no base fees or anything like that, just $1.50 per cubic meter, which is just slightly less than the average cost of water in the States. So you say if those homes that didn't use any water, when it's volumetric, they would pay zero because they didn't use any water. But the average of that whole graph would be $98 per billing cycle per quarter. And the maximum would be $308, and the utility would generate $14 million in revenue. Then I said, let's put in that base fee like a lot of municipalities do and charge them $35 no matter what. Now we still want the revenues to be $14 million because we can't charge them more than what we need. So now we have a base fee of $35, so the people that don't use anything pay $35, but now, and the average is still $98 mathematically, but now the maximum is $233. So the maximum bill is reduced. So I said, well, what if because we still want to charge the people that don't use any water something because we have a water meter there and somebody had to read the water meter. So what if we put a minimum fee in instead? Then we have a minimum fee of $35, but once you use more than $35, then you just pay on a volumetric. Again, the average is 98, and the maximum is 308, and the total is 14 million. But if you're trying to get people to reduce water, which one do you think is more impactful for the people that abuse water, a $233 bill or a $308 water bill? And I've had so many arguments with people for rates for this. But that is almost the end. So are water efficiency programs reaching the end of the line? No, they're not. But the typical rebate type programs, I believe, are, except in very water scarce area. If you're on a well system or a river system where you can't wait for the natural decline of 1.2 or 1.5 gallons per capita per day per year, then you need to accelerate that. But if you can wait, then why pay for it? Shift your focus to somewhere else. So water efficiency plans will have to evolve, and they'll have to start focusing on irrigation, more focus on non-residential water demands, low impact development, and more effective education, because I think we do have an opportunity to change behavior. If we can get people to realize to take shorter showers and to take maybe one less shower a week and to wash their clothes one less time a week, then we can actually accomplish something. But for the indoor single family, I think we've almost hit there. And that was pretty quick, wasn't it?
Well, thank you, Bill. And any questions for Bill from the audience?
No questions.
After
Thank
he
you.
skewered all those sacred cows? Go ahead, Greg.
I'd like to make a comment that your 40 gallon per day per person is doable. I have water bill proof, and I'm on a water district with a meter. I've gotten on four different occasions with 2 months per billing cycle, I've gotten a 100 gallon daily use total.
Yep.
And there's 2 people in my house, my wife and I. And that includes the 20 office visitors that come to her home-based office that use the bathroom. So 50 gallons a day per person is possible. I've been doing it now for about a year.
Well, 40 gallons is easily possible. We have
very easily possible.
All kinds of new homes are built with less than 40 gallons a day. But when you talk to people who have been in the industry for 20 years and you go, you need to accept that this is going to happen, they don't want to accept it. And they keep saying this is an anomaly, and sooner or later the demands have to go up.
Okay, we have a question over here.
Yeah. Bill, I thought your trend analysis was really very astute and right on target with regard to indoor water use. One thing I'd mention or suggest looking at in terms of outdoor water use, in terms of these broader trends, might be the impact of smart growth policies, efforts to make new development more transit-friendly, communities more walkable. That suggests more multifamily housing, maybe a little bit different mix of multifamily housing and single-family housing, and potentially smaller yards. To the extent that communities are more walkable, there's going to be less yard space, and that could be putting downward pressure on outdoor water use in the years ahead, as well as pricing, as you noted.
As well as pricing. Also, we want to try and get away from, much as they do in Vegas, is to get away from everybody having the same cookie cutter lawns. They have a front lawn that they never use. They walk past it to get to their home. They use part of their backyard, but they don't do anything with that front yard. So why do we need grass there? Also, as more and more immigrants come in, a lot of the immigrants are from countries where they live in multi-res buildings, whereas we typically want the single-family homes. They're more content to live in multi-res, so yeah, hopefully it will have an impact.
Now that you made Doug Bennett think about disappearing revenue, he's got a question.
Uh-huh.
Well, not so much a question, but I guess a clarification. So I work with water utilities, obviously, and when you mentioned that if it was purely a volumetric pricing structure, you can't actually charge people zero if they use no water because they still cost you money. You still have to go read that zero consumption meter. You still have to mail them a bill for $0, so forth and so on. So a lot of them have a service charge that's based upon the cost recovery of just providing those basic services. And I also want to comment on your S graph there.
Just before you go there,
Yeah.
but I did agree with that. I say instead of a base fee, though, it should be a minimum fee, because then we have more impact on the high water users. We still get that, whatever it is, $35.
Well, I just wanted to clarify. You
Yeah.
said it was because they wanted to make sure they had the revenue, but some of them just charge
Right.
it to make sure they covered very
Right.
basic costs.
No, and in
on this
fact,
house.
I maybe misspoke there. What I wanted to say is what I hear from them is we need to protect your revenue, and I go, that doesn't
Yeah.
protect your revenue. That only covers those costs. Yeah.
I probably agree with that.
Okay.
Just to point out, I did that same analysis in the city of Albuquerque and also in southern Nevada of the percentage of users, or I guess a decile study.
Yeah.
And in both cases, the top 10% of residential water users used as much water as the bottom 50% of residential
It's
water
incredible.
users. So almost every city is going to have those same characteristics with extraordinary water users.
That's true. What we're starting to do up north is we're not concentrating any outdoor programs on the hose draggers, but we're really starting to focus on the homes that use a lot of water. Like you said, you target. If somebody doesn't have grass, don't send them something on getting rid of your grass, right? So we're trying to identify the homes. Getting the water billing data is somewhat difficult sometimes because it's hard to get from the utility. But if we can target the homes that are using, and some of them are using huge amounts of water, like you said, we're the top 10%, you go, if you got rid of those, you would cut your production by like 40% or something. It's incredible. Well, thank you very much for sticking around.
Thank you, Bill.